It is day 4 in Algebra 2, and this is the last day of your first week, which is awesome. So just a quick reminder, we do not have class on Fridays, which is really cool because that gives you guys time if you need to come in and get a little extra help. We will have office hours tomorrow where I will be available from 9 a.m. until noon. At that time, if there are things you need help with, if you need to turn things in, you are welcome to come in here and work, ask questions, do whatever you need to do. So, just wanted to mention that. And I'm going to title this worksheet Day 4. This was kind of our big now. Thursday, March 27th. So on this worksheet, there are 35 trinomials, quadratics, front and back. There's a whole bunch of them. The first 15 are quadratics where a equals 1. So we did a lot of practice with that the last 2 days. And if you worked on those, that is great. But we also started introducing some like number 16 through 35, where we have a bigger than 1. That changes the way we do things a little bit. So we'll start by doing maybe 1 or 2 from the first half of this worksheet. And then we're going to focus a little more on the tougher ones. So from number 1 to 15, were there any that stuck out to you guys, maybe gave you a little trouble? Or did they feel easy? How do you feel about these? Pretty good. Pretty good? Good. Was there any that felt difficult, or are we really just feeling great about it now?
I'm on number 20. I didn't finish it, but I'm looking at it right now and I'm kind of stuck on it.
Okay, let's start with number 20 then. Why not? Now, this is one where a is greater than 1. So we might skip around on this worksheet a little bit, but we'll start on 20. All right. So number 20, I have 2x squared plus 16x minus 32. Whenever our a, and again, a being the number attached to our first term, b being the number attached to the second term, 16, and c being the number at the end, or negative 32. When our a is 2 here, what's the first thing we should look for to help us solve for factors here?
Greatest common factor.
Greatest common factor. I want to see, can I divide all 3 terms by something, by some number? Does there have, or is there a greatest common factor here? Yes. What is it?
2.
2. So I can take 2x squared divided by 2. I can do 16x divided by 2. And I can do negative 32 divided by 2. So let's start with that. We'll divide everything by 2. And if I divide everything by a number, that number needs to be included in our answer so that we still have that same original quadratic. So now I'm going to have 2 on the outside of my parentheses, and we're going to reduce each of our terms. So 2x squared divided by 2, what does that become? Just x squared. The 2's would cancel. Okay, now I have 16x divided by 2. What does that become?
Plus 8.
Plus 8x. And negative 32 divided by 2.
Negative 16.
Negative 16. Good. Okay. So now I have my reduced problem. I have 2 times x squared plus 8x minus 16. So we now have a new value for A, B, and C. What's our new A? 1. What's our new B? 8. And our new C? Negative 16. Good. Now that we have an A of 1, we can factor like normal. So we will go through that process that we've been doing the last few days, where we begin by listing out all the factors of C. So since C is negative, we have negative 16. What are the possible signs of our factor pairs?
116.
Now, 1 and 16 are correct, but what signs should either
Negative.
1 or 16 have? Yes, we need a negative number and a positive number. So I like to just start by putting negatives on the first number. So we've got negative 1 times 16. Let's go down the line. Negative 2 times
8.
8. Can't do 3. Negative 4 and positive 4. Are there any more? I can't do 5. I can't do 6. I can't do 7. I can do negative 8 and 2. Let's do that. Negative 8 and positive 2. So now what we're doing is we're flip-flopping the numbers. And whenever we have one negative and one positive, it's good to list out all of the possibilities. Negative 2 and positive 8, also negative 8 and positive 2. Now the 4's, it's the same number, so we're not going to flip-flop that. But now we also have negative 16 and positive 1. So here's all of our possibilities. How can I figure out which one of these pairs of numbers to use, if any? What do I do to check? You're going to add the pairs together. So what is negative 1 plus 16? 15. Okay. And negative 2 plus 8? 6. Negative 4 plus 4?
8.
Negative 4 plus 4?
Negative 8.
0. So if I have a negative 4, I'm like this. 1, 2, 3. Negative 4. Here's my starting point, and I add 4. 1, 2, 3, 4. I end up at 0. So anytime you have the same number but different signs, when you add them together, they cancel out to 0. So we have negative 4 plus 4 is 0. How about negative 8 plus 2?
Negative 6.
Negative 6. Negative 16 and 1.
Negative 15.
Negative 15. Okay, so here are all of the answers to each of the pairs added together. What do the pairs need to add up to?
8.
8. My middle term is 8. Do any of these work? No. If we go through every single option like this and none of them work, that means this is the farthest we can go. We were able to factor out a 2, but we couldn't go any further. So this would be our answer. That was a tricky one for sure. This would be our answer as far as we can go. Unless, did someone else do something different?
I don't know how I ended up with it. I ended up factoring out 2 and then in parentheses x plus 4, x plus 4.
X plus 4, x plus 4. So
I think what I did was when I factored my negative.
did you change your 16 to positive 16?
No, I wrote negative 16, but I was trying to solve for 8. So I added my 4 plus 4.
Gotcha. So that makes sense. 4 plus 4 would give us 8. Absolutely. But 4 times 4 won't give us negative 16.
Okay.
So that's why it won't work. This is, I think, one of the trickiest part of factoring is remembering what signs your factor pairs are allowed to have. If your ending term, your C, is a negative number, your factors must have one positive number and one negative number. They have to. The only time that your factors will have two positives or two negatives is if your C is positive. If it's negative, your signs must be different. If it's positive, they can be the same. Okay. Any questions about this one? Other than that, I appreciate you guys, speaking out. It's helpful. These are tricky because we're always going to second guess ourselves a million times. You're going to be thinking, I must be missing something. You're not. If you can't do it with any of the pairs, that's as far as we can go. Any other questions, or does anyone else have another number that they think might be tricky that we could look at together? He gave us specific.
I want to just test one out just to make sure
Yeah.
I'm doing it right. Let's do 18.
18. Okay, let's do 18. Okay, so 18. I have 3x squared minus 15x plus 18. Label our ABC. A is 3. My B is negative 15. And my C is positive 18. Now, what should we do here since our A is not 1?
Divide everything.
Yeah, let's find the greatest common factor and we're going to start dividing. And usually I'm going to always recommend I would try using whatever your value for A as GCF first. See if you can reduce it that way. Because if you can, it's going to make it a lot easier. So we'll divide everything by 3. Let's see if that works. Divide by 3. 3. Divide by 3. Let's see if I can make that bigger for you guys. And I'll make it not blurry. There we go. Okay, so we have divided by 3. What do I do next?
My train of thought. Simplify it.
Yeah, let's simplify it. So where does that 3 go?
That 3 goes out to the side.
Good. Put it out to the
See,
side.
yeah. And that leaves you with x squared
Mm-hmm.
minus 5
Yes, minus 5
plus 6.
plus 6. Perfect. Perfect. So at this point, we have a new A, B, and C. Let's look at them. A is 1, B is negative 5, and C positive 6. So now that our A has been reduced to 1, what can we do here? Yes, let's find the factors of C, and C is positive 6. Now, what are my factors going to need to add up to? Negative 5. So I will just write that over here again, just so I can kind of keep it in mind as I do this. So I need number pairs that multiply to positive 6, but add to negative 5.
They'll both have to be negative.
They're both going to have to be negative. Why is that? Why do we have to?
Negative and negative multiplied by each other equals a positive, but when I add them together, it stays the same.
Perfect, perfect. Whenever I multiply a negative number times a negative number, I will get a positive number. Whenever I add two negatives, I will get a negative number. So let's work with negative factors. And we can just start from the smallest, negative 1 and negative 6. What's the next factor?
-2 and 3.
Good. -2 and -3. And we can stop there. What's -2 plus -3?
-5.
-5. We found it. Okay, so since -2 and -3 do indeed add up to -5, these are going to be the numbers we use. Now, how will we use them?
You're gonna put the 3, and then in parentheses, it's gonna be x minus 2,
X minus 2
and then x minus 3.
and X minus 3. And that is your answer. Awesome, awesome. Good stuff. Okay. Any questions about number 18? Are there any other problems on this first page here that we would like to look over together?
Oh, with 27 on that.
27 on the back, absolutely. Let's do that. 27, okay. Yeah, here's where they start getting tricky. So, for number 27, my A is not 1. What is A? 10. My A is 10. My B is 17. And my C is 3. Is there a greatest common factor? Is there? What is it?
10.
10? Okay, so I can do 10 divided by 10. Can I do 17 divided by 10?
Mm.
You can only divide a number by 10
Ignore me.
if it ends in a 0. No, you're okay. You're okay. So there actually is not a greatest common factor here. I have 10, I have 17, which you may remember back in grade school or not. 17 and 3 are both what we call prime numbers. Prime numbers cannot be divided by anything except for 1 and themselves. So there is not a greatest common factor here. We can't divide anything out to reduce our A. This is a tricky one. Whenever we cannot reduce A to 1, we talked briefly about this yesterday. What are we going to have to do with that A? Well, we can't get rid of it. We tried to.
Have to include it.
We're going to have to include it. We're going to have to include it. So on the problems that we just did, we were able to take our A and get rid of it by putting it outside, like this. Our A was 3, now it's outside the factors. The A was 2, now it's outside. Over here on number 27, I cannot divide everything by 10. So 10 is going to have to be in front of one of my x's whenever I factor. Now, this is where the guess and check starts happening. And for this problem, I am going to get my separate sheet of paper out because I don't think our work's going to fit on the worksheet. And I'm going to rewrite the problem. So, let's see. 27 is 10x squared. So let's make a little note to the side again. I'll say when A is not equal to 1, and there is no GCF, whatever your A value is included in your answer for your factors. Will be included in your factors. Meaning you'll end up having something like AX plus or minus something times X plus or minus something. So we're adding A in there. So I'm going to go ahead and write out what I did on that worksheet earlier. We're going to try 10x plus or minus x. Like that. Now, whenever you have to include A in your factors, when we find the factors of C, we're not going to be able to check which numbers work just by adding the pairs together. This is where the rainbow method comes in. And if you aren't familiar with that from yesterday, I'm going to reteach it today a little, give you some review on it. So let's start by listing the factors of C. What are the factors of C?
1 and 3.
1 and 3. Or we could do 3 and 1. But that's it. There's only 2 options. 1 times 3 or 3 times 1. So let's start plugging these in and see if we can come up with one that works. And if none work, there's something else we'll have to do. So let's see. Get another color. Let's try 10x plus 1 and x plus 3. We're trying the first pair first. 1 and 3. So once we plug these in, we're going to see if it works. We need to multiply our middle terms. So what is 1 times x? 1x. And then we'll also multiply our outer terms. And here's where that rainbow appears. This is our rainbow method. So what is 10x times 3?
30.
30x. Okay. Now, we're going to add these together and see if they add up to our middle term, our 17x. 30x plus 1x, is that going to add up to 17x? No, it won't. So 31x, that's not equal to 17x. Doesn't work. We're going to try the next option. Let's do 10x plus 3 and then x plus 1. So now we're trying the second pair of factors. Now, we're going to multiply our middle terms. What is 3 times x?
3x.
3x. And 10x times 1, that's just 10x. What is 3x plus 10x?
13x.
13x. That is not 17x. So, this doesn't work either. No. Now, here's where the super fun part starts. If these don't work, there's another thing we're going to try. I know. Oh, this is the part that I did not like in factoring in high school. But the more we do this, the more it actually will start to become sort of satisfying because it's like a riddle. You're trying to solve it. So now we're gonna go back to our original problem, okay? And we're gonna do a lot with this today. We have our 10x squared plus 17x plus 3. Since we couldn't do, I'm gonna rewrite it and move this sheet down. 10x squared plus 17x plus 3. Okay. So we tried both options where we have 10x in the first set of parentheses and x in the second set. It didn't work with 1 and 3 or 3 and 1. So since we cannot have 10x and regular just x, we're going to try breaking up our first term by looking at its factors. Now, 10x squared, let's see. Some of the factors of 10, what we used above were 10 and 1. That's what we did. So 10 and 1, that's a pair of factors, but we know it doesn't work. What other two numbers could we multiply together to get 10?
2
and 5. So I know 10 and 1 don't work. I'll cross that off. Let's try 2 and 5 next. So now we will try 2x and 5x. And we will repeat the same process as above, where we are just going to guess and check using the rainbow method with our factors of 3. So I'll just list those factors again. It's just 1 and 3 or 3 and 1. Those are our options. Okay. So let's try 1 and 3 first. Let's do 2x plus 1 and 5x plus 3. Right. Now, how can I check to see if this works?
Rainbow method.
Rainbow method. So what am I doing to do the rainbow method? How do I do that?
The inside and on the outside.
Yeah, let's multiply our inside terms and our outside terms and then add them together. So what is 1 times 5x? 5x. 2x times 3? 6x. 5x plus 6x is? 11x. Does this equal our middle term? Oh, what? It doesn't. 17x. Nope, it's not the same. So, well, we know another option that won't work. Let's try the last one. 3 and 1. Try 2x plus 3 and 5x plus 1. And we'll hope and pray this one finally works. Let's try our rainbow method. We'll multiply our inner terms. What's 3 times 5x?
15x.
15x. And 2x times 1?
2x.
2x. Hallelujah. Okay. 15x plus 2x is?
17x.
17x. We did it! So, this is our answer. After all that. Woo! It's some pretty long-winded stuff. But I promise, the more we do this, the easier it will get. You might not believe me, but it will. It really will. Okay, so we have our final answer. We're going to run through a bunch more just like this. just like this. So let me find some that I know don't have greatest common factor. Let's look at number 28 next. Before we do though, does anyone have questions about what on earth we just did? And it's okay if you don't even know what to ask. I think we're gonna do a few more just like this, and hopefully it will start to come together a little more. I'm gonna try to make you guys some guides to help you know if this doesn't work, where should I go next? I think sometimes that's the toughest part is once one step doesn't work, you feel stuck. It's like, where do I even go from here? So I'm gonna try and give you guys some guidance to make that not feel so tough. Does anyone still need to see this page? Okay, I'm gonna move it. And I'm actually gonna title this before I move it because I don't wanna lose it. This is Algebra 2. Day 4. So on that worksheet, we're gonna look at number 28 now, and I actually think that 28 to 35, while I'm glancing at these, it looks like none of them have a greatest common factor. Actually, the whole back side. Yeah, I think none of them on the back side are gonna have a greatest common factor. So that's good. We're gonna have a lot of good practice here. All right. So we're gonna do number 28 on that worksheet, which is 9x squared minus 9x plus 2. Okay. And before we go through solving, this is actually gonna. So off to the side, I'm gonna draw a little guide out for us that hopefully we might find a little helpful. Because I did just find it, and I lost it again. It's in the middle. So I'm gonna write step 1. First thing we always do is check to see, is there a greatest common factor? So check for GCF, and in parentheses, I'll say, can I divide every term by a number? Not just by a number, by the same number. So, step 1. Can I divide every term by the same number?
No.
No, you can't. 9, 9, and 2 doesn't work. Cannot divide all three terms by the same number. So next, we are going to go to step 2, which is to list out the factors of C. Now, since we cannot remove A, what do we need to do with A? We need to include it. So, since the answer is no to step 1, that means we're going to write 9x for our first pair, and then we'll write x for our second pair. Now, it is always possible that 9x and x won't work. So, we'll get there when we get there. But let's do our step 2, which is listing out the factors of C, or 2. What are all the factors of 2?
1 and 2.
1 and 2, or 2 and 1, that's it. 1 and 2, or 2 and 1. You only have those options. Now, we've got that. Step 2 done. What should we do from here?
We need to see which one of them, those two sets of numbers works.
Yeah, let's go ahead and try plugging these in and seeing if any of them work. So, I'm also actually, I think what might be more helpful than trying to reason everything out is let's actually list all factors of positive 2. We can have 2 positive numbers. What's the other option?
2 negatives.
2 negatives. So we actually have 4 options. We could do -1 times -2 or -2 times -1. Now, whenever we go to step 3, this is where we do the rainbow method. We are going to guess and check their factors using rainbow method. So we will go ahead and do that now. Now, whenever we're using the rainbow method, we're checking to see that whenever I multiply my inner terms, my outer terms, and then add those together, what should it add up to? -9, exactly, perfect. So, which pair should we try first? There's not a correct answer. What pair do you guys want to try first?
-1 and -2.
Sure, let's try -1 and -2. So, -1, -2. See if that works. -1 times x gives me what?
-1x.
-1x. 9x times -2, what's that give me?
-18x.
-18x. When I add these together, I get negative 19x. This does not work, does it? It's not equal to negative 9x. So we know that won't work. That's not going to work. Now I'm going to write that out again. But let's switch negative 1 and negative 2. Let's do negative 2 and negative 1, like this. Now, the more we do these, you may start to get to a point where you can kind of predict the outcome before writing all the answers out. 2 times x is, well, negative 2x, negative 9x. That's not going to add up to negative 9. We know it's not. It's going to be 9, 10, 11, negative 11. I'll write out the work just for good measure. So we got negative 2x and negative 9x. When we add them together, we do get that negative 11x. So this doesn't work either. Does not. So when we have tried all of our options, technically we still have the positive options, but are those going to work? We're just going to get the positive versions of the same answer. Okay, so we know it's not going to work. So obviously 9x and x are not the best choices. We can go further. So here is where step 4 comes in. If this is too light of a color. See that. Step 4. None of the options work. We're going to try factoring A. We're going to factor A and put its factors with each of the x's. So instead of, we really did factor A here and you don't even realize it. 9x times x is 9x squared. That's why we broke it up into those two pieces. There are other numbers we can use besides 9 and 1 to get to 9. So if none of the options work, try other factors of A. Here's where I'm going to rewrite that problem. 9x squared minus 9x plus 2. So, factors of 9. We have 9 and 1. That did not work. We already tried it. Didn't work. What are other options?
3 and 3.
3 and 3. So 3 times 3 gives us 9. 3x times 3x will give us 9x squared. So let's try that. Let's try 3x and 3x. So now that we're trying different factors of A, we're going to do that step 3 all over again. We're going to guess and check each pair of factors using the rainbow method. So I'm just going to write under here, repeat step 3. factors of 2. We'll just go back to that list that we tried. You're welcome to rewrite it so that it's not all crossed out already. You don't have to, but I think I might. I will. So we have 1, 2, 2 and 1, -1, -2, -2, -1. Of those 4 pairs, which one do we want to try first?
Let's do 2 and 1.
+2 or -2?
2, then positive.
Positive? Okay, let's try that. Let's try it. +2 + 1. Okay. What's 2 times 3x?
6x.
6x. What's 3x times 1?
3x.
3x. What is 6x plus 3x? 9x. Is that equal to -9x? No. But it's the right number. Wrong sign, right number. So, what does that mean?
Means we just gotta do the negative.
We're just going to do same numbers, different sign. We know our answer is going to be 3x minus 2 and 3x minus 1. If you want to feel really good about it, we can double check again with the rainbow method. So why not? Let's do it. -2 times 3x is -6x. 3x times -1 is -3x. And when you add these together, you do get -9x. So this is our answer. Yeah. This is a long process. It can feel exhausting. It really, I totally get it. I will tell you, last term, some of my students that struggled the most in math, I'm telling you, the first time that we did this process, some of them walked out about in tears. By the end of this unit, they were getting A's on their factoring quiz. It will start to feel more comfortable. It will, I promise you. This is something that you may have never seen before in your life. And learning something new, especially like this, it is genuinely like learning another language. And it is not easy, but you guys are doing really well. This is not easy stuff, but you will get it. This is the first time I showed it to you. Okay, this is hard. Yes.
What about the ladder?
Oh, the ladder method of finding GCF?
Yeah.
Yes. Okay. Quick off-topic note. This will be a little brain break for us. I'm going to teach you something a little easier that might help us with this process in general. So, does anyone still need this? After I show you this last thing, I'm going to give you a break. I'll give you a longer break today. I think we're going to need it. This is a heavy lesson. Okay. So, if you sometimes struggle to find the greatest common factor, I think I'm guilty of skipping over and assuming everyone knows how to find the greatest common factor. Some of you don't. That's okay. I'm going to teach you a really easy way to do it. So let me just title this page. Thank you for saying something, Lisa. Sometimes I get ahead of myself. Don't ever be afraid, you guys, to speak up and tell me to slow down or tell me to go back and re-explain something. I will never be offended by that. Sometimes I need to be brought back to earth and reminded, like, maybe some of y'all need a little help with some of this. That's okay. That is my job. What I'm here for. So, day 4 notes confirmed. I don't know why I wrote this so big. Okay. So, this is a little mini lesson. How to find the greatest common factor. And this is called the ladder method, using the method. So I am going to write out a problem, and we're not going to factor it. We're not going to do anything crazy with it. We're just going to find the greatest common factor. Let's do example 10x squared plus 50x plus 40. So let's pretend that upon looking at this, you don't recognize right away that 10 is the greatest common factor. Let's say we don't know that. Okay, so here's what we can do to find the greatest common factor and to find what goes inside your parentheses when you're done. You are going to have all of it done real easy in one quick method here. So what we do is we take our quadratic and we are going to put a big L under it. This would be the first step of our lab. And what we will do is off to the side, we're going to start with small values and see, can I divide all three terms by a number? So for example, I like to start with 2. 2 is a great number to start with. So let's do that. I am going to put 2 right here. And then let's divide everything by 2. So 10x squared divided by 2, what is that?
5x squared.
Good, 5x squared. Bring down my plus sign. 50x divided by 2, what is that?
5x.
Good, 25x. And 40 divided by 2, what is that?
20.
20. Okay, so there's our first step. I can take 2 out, that's a factor. Now we are going to make another step on our ladder. And I'll just use another color to separate it. Can I divide all 3 terms by another number?
Yeah.
What is that?
5.
5. Okay, so let's try that now. What's 5x squared divided by 5?
X squared.
X squared. Bring down my plus. 25x divided by 5.
5x.
Perfect. 5x. And my plus sign again. 20 divided by 5. 4. Now I can look at all 3 terms and let's see, can I divide them by anything else?
Yeah, no.
No, I can't. I have an A of 1, so we know we've reduced as far as we can go. Plus, these 2 numbers do not have any common factors. So, here's what happens. Whenever you have gone as far as you can go, this is what goes inside the parentheses. And whatever is on the outside, you multiply. What is 2 times 5? 10. And that is what goes here. So this is another method of finding your greatest common factor if you are having trouble with that. Because in the future, there will be problems where you won't be able to tell right away, you know, these are all factors of 10, they all end in 0. This is an easy example. There might be problems where you have to divide by 2 about 7 times, and then you realize, oh, 14 is the factor. That might have been harder to notice at first. So we may end up using this a little more in the future on problems like that, but this is just to kind of show you another way of finding it. And hopefully it helps a little. All right, right on time. It's 10:25. You guys need a break. Let's do. I don't want you coming back here until after 10:45. I mean, take at least 20 minutes. Take at least 20 minutes. So, all right, no, take a break. I will see you back after that break. And of course, you can stay in here if you want. I don't want you to feel like I'm kicking you out. So we are back from our break. We just talked about finding the greatest common factor, just as a little review. So head back to that worksheet, and we're going to run through some more together. I'll clear this out. And I do want to remind you guys, again, if you ever miss a day or you miss part of a class, come find me after class. If you want copies of the notes you missed, I'm always happy to do that. So just ask me. I won't know unless you ask. Okay. So we just did problem number 28. Let's look at 29 now on the back. So problem 29 is 5x squared plus 11x plus 6. So going back to those steps we wrote out, 4 steps. Let's see. We're going to check for our greatest common factor. Is there a greatest common factor? No, there's not. There's not any numbers that I can divide 5, 11, and 6 evenly by. So now we're going to go to step 2, which is to just list out the factors of C like normal. So I'm going to write A, B, C up here. The value of C is positive 6. So what are all the factors of positive 6?
1 and 6.
1 and 6.
2 and 3.
2 and 3. And we could also flip-flop those numbers as well, since we're going to have different numbers in our parentheses. So let's also just write for fun 6 and 1, 3 and 2. Okay. Now, since our A is greater than 1, no matter what we do, when we add these pairs of factors together, we are not going to end up with an answer of our middle term, B, which is 11. So this is where we move to the third step, which is to start guessing and checking using the rainbow method. So since we could not reduce our A to 1, what will we do with A in our answer?
Included.
We're going to include it. So let's try 5x and x. pair do we want to try first?
1 and 6.
1 and 6. Let's do that. Okay. So let's try +1 +6. And we'll do our rainbow method. We're going to multiply our inner and outer terms. What is 1 times x?
1x,
1x. 5x times 6?
30x.
30x. 1x plus 30x is 31x. Is this equal to our middle term? No, it's not. So what does that mean for us?
Try again.
We're going to try again. This was not the correct pairs. So we need to try another idea. Cross off 1 and 6. We don't have to go in order down the line. We can jump around if there's one that you think might work better. Which pair of factors should we try next?
3 and 3.
Which one? Say it again.
3 and 2.
3 and 2? Why not? Let's do it. 3 and 2. Okay, so let's write our 5x and x again, and we'll try 3 and 2. So +3 +2. Let's do some multiplication. 3 times x is 3x. And 5x times 2, what is that?
15.
Almost. 5x times 3 would be 15. What's 5x times 2? 10x. Good. So 3x plus 10x, what does that give us?
13x.
13x. Is that equal to our middle term? No, it's not. So 3 and 2 won't work. We'll cross that off. Want to try next?
6 and 1.
6 and 1. Let's do it. This time I'll write it over here. 5x and x. Let's try 6 and 1. Use the rainbow method. What is 6 times x?
6x.
6x. 5x times 1?
5x.
5x. 6x plus 5x is 11x. Is that equal to our middle term?
Yeah.
Yes! So what's this mean? This is the answer. This is correct. We found it. It's our answer. Again, it's a long process sometimes, but the more we do it, the quicker we'll start to recognize which one's going to work. Perfect. Any questions about this problem before we do another? Scooch down a little. Let's try number 30. This one might be a little bit easier. Got small numbers here, nice small numbers. Number 30, we have 3x squared plus 2x minus 1. Do we have a greatest common factor? Nope, we don't. No greatest common factor. So what do we do?
Include the A.
We're gonna include the A. Our A is 3, our B is 2, our C is -1. So we'll try 3x and x. So now that we have our parentheses filled out, what should we do next? Not a 2. So we figured out there was no greatest common factor. That's why we're including 3 in our answer. And now we're finding factors of
-1.
-1. We're going to find the factors with C. -1. And not many options.
So you're gonna be 1 and -1 or -1 and 1.
Yeah. We have 2 options. We have -1 and +1, or +1 and -1. Remember, if your number is negative, your factors have to have different signs, one positive, one negative. So now we have our 2 options. Which one should we try first?
-1.
Sure, let's just go down the line. -1 and +1. Let's see what happens. What is -1 times x?
-1x.
-1x. And 3x times 1?
3x.
3x. Now we'll add them together. -1x plus 3x is
-2.
not -2, +2. Good. 2x. Is this equal to our middle term?
Yeah.
Yes, we got it on the first try. So because it is equal to 2x, our middle term, this is our answer. Sometimes we get lucky. That one wasn't so bad. Not too bad. All right. Let's do another one.
Do 25.
Yeah, let's do 25. Okay. 25. I'm going to start a new page because this one might take a little longer. Before I do that, I don't want to rip this out before you are done writing. Does anyone need to see this still? That good? So number 25. I'll write the problem down and then I'll type on the page. We've got 6x squared plus 5x plus 1. It's page 5. Okay. So our A is greater than 1. It is 6. Is there a greatest common factor?
No.
No, there's not. You can't do anything except for divide them all by 1, and that won't change our numbers. So, because there's no greatest common factor, what does that tell us about our 2-factor pairs? Our binomials.
They need to include A.
We need to include A. Now, I'm going to jump ahead and talk about the options here. We normally would say, okay, let's include A. We could do 6x and x, right? If this doesn't work, what would our other option be?
The GCF of it.
find so it wouldn't technically be called GCF. Greatest common factor is when we're referring to factors of multiple numbers or multiple terms. If we're finding it for just one item, we would just call it a factor.
Okay.
So we are looking at the factors of 6x squared. 6x times x gives us 6x squared. What else could I do to make 6x squared?
3x
Yep,
and 2x.
3x and 2x. Now, I'm going to challenge you guys to use some reasoning skills here. And let's just think about this problem before we start writing a bunch of stuff down. We have options. We could start listing out the factors of 1, which are just going to be 1 and 1, no matter what. There's no difference there. So if I put 1 here and 1 here, is this ever going to add up to 5x? No, because 6 is already bigger than 5, and we're using positive numbers. So we could reasonably think about the next option. I know that 3 times 1, when I put it in, and 2 times 1 is going to be 2x plus 3x, which is 5x. This will be our answer. Now, I'm going to still walk us through the process slowly, but as we do more of these, that little reasoning process is going to start working harder, and you will start to recognize which things will and won't work. So let's see. Let's go through that process again. Let's list the factors of C, which are factors of 1. You can only multiply 1 times 1 to get 1. 1 and 1. You could also do -1 times -1, but we don't want to use negative numbers when our middle term is positive. So if we were going down the line, doing the 6x and x first, we could try plugging in our 1s. +1, +1. Okay, and this is where we would start doing that rainbow method, right? 1 times x and 6x times 1. I know I'm writing it slightly different. I'm trying to conserve space. 1 times x is what? 1x. 6x times 1, that's 6x. 1x plus 6x is 7x. And that is not equal to our middle term. So we know this won't work. Now let's look here. We only have one option, 1 and 1. Plug them in. And then we'll do that rainbow method again. 1 times 2x is
2x,
2x. 3x times 1,
3x.
3x. 2x plus 3x is
5x.
equal to our middle term? It is. So this is our answer. 3x plus 1 times 2x plus 1. Perfect. Number 25, do we have any questions about that one? Any other ones on the sheet that are sticking out to us? Any that anyone would like me to work out specifically? If not, I'll just keep going down the line. Let's I want the special case. What if I gave you, this one won't be on the worksheet, I'm gonna give you a separate problem. How about 6x squared or x minus 2. Six x squared plus 4x minus 2. What should we do first when we notice that our first term is not 1 squared? What should we do first? You will include it if we can't make it smaller, right? Can we make this smaller? Can we get rid of it?
Yeah, we can, it's -2.
There's a greatest common factor here. There is. We can divide every term by a number. We can divide everything by 2, can't we? Okay, so how about let's do that? Let's divide by 2. Now, if I divide everything by 2, when I take out a factor, where does that go in my answer? Do I include it or does it go outside?
Yeah, it goes on the outside.
It goes on the outside. So I'm taking 2 out. And then we're going to reduce. I want to see what am I left with when I divide each of my terms. So 6x squared divided by 2. What is that?
3x squared.
3x squared. Plus 4x divided by 2.
2x.
2x. And I'll bring down my minus sign. Minus 2 or -2 divided by 2. -1. Okay, so going back to those steps, let me put those back up on the board for a second. First thing we're doing here is we check for a greatest common factor. If there is a greatest common factor, we put it outside. Right? Now, we can't reduce this any further, can we? We can't. There is no other number that I can divide all my terms by. So we're going to go ahead on to step 2. We're going to leave that 2 on the outside and just let it hang out. And we're going to treat this like the past couple of problems we've been solving. We're going to go to step 2 and list out our factors of C. Let's do that. So A is 3 now. B is 2. C is -1. What are the possible factors of -1?
-1 and 1.
-1 and +1.
+1 and -1.
You could also do +1 and -1. Awesome. So we've got those listed out. Now, whenever we make our sets, our parentheses for the binomials, because our A is not 1, what do we do with it? We're going to include it. I'm going to include 3x here in my first pair, and then x in my next pair. Now, the only thing not to forget to do is, since we did find greatest common factor, we're going to bring that down with us as we do each step. So the only thing different here is we not only have a 3x and x, but we also have a 2 on the outside. So we listed out our factors. So now we can go to step 3, where we can guess and check each pair of factors using our rainbow method. So we'll just go down the line. Let's try -1 and +1. Let's just see if it works. Whenever we do the rainbow method, which middle term are we looking at now? The 2x or the 4x?
2x.
2x. Now, since we reduced it, we divided by 2, and it's outside. We are looking at the b of the most recent quadratic. We're looking at the one directly above. Don't go all the way back to 4. We got rid of 4. Now we have 2. So let's do our rainbow method. -1x and 3x times 1 is that positive 3x. And what do we get when we add these together?
2x.
2x. Is this equal to our middle term?
Yes.
Yes, it is. So this is our answer. This whole thing is our answer. Is our answer. It's in factored form. So sometimes there will be a greatest common factor, but that greatest common factor might not reduce it down to 1. You may still need to include your a in your factors. There's a lot of moving parts to factoring. A lot of moving parts. I know it can get kind of confusing, but you guys are doing really great with this. Okay. Do we have any questions about what I just showed you? Any questions at all? I feel like I'm abusing you today. I sense stress, and I don't want you guys to feel stressed. So I know I'm introducing you this kind of more in-depth stuff today, and it's a little tricky, but I don't want anybody to be feeling nervous because, first of all, I'm not grading you on your ability to do this today. Okay? It is Thursday. I will not give exit tickets on Thursdays so that you have plenty of time to make corrections and things. I'm introducing this to you today, and we're practicing it so that you know if this is difficult for you today and you're feeling a little confused, tomorrow would be a great day to come in. Happy to sit with you and help you a little more one-on-one. And of course, if you're not able to do that, then we will be doing more of this on Monday too. So don't feel like I'm gonna show you this and we'll move on and I'm gonna leave you behind. Okay, we will be okay. Everything will be just fine. So there's another example. Here's what I'm gonna offer to you guys for the rest of today's class. I have another worksheet with a bunch of these slightly tougher problems where your A is not 1. I am going to have this available for you guys if you would like to do more practice. If you feel good about this, you think I got this, I don't really need more practice, I'm going to let you go. Okay. If, however, you would like to practice more, or maybe you just enjoy math, maybe you don't need the practice, you just want it, feel free to stay and we will do more practice. But if at this point you feel good about what we've been doing today, don't feel like you have to stay. Enjoy your weekend. So I'm going to pause our recording here and I'll set out these worksheets for everybody.